Welcome, geometry students, to the homework help video, lesson 2.3, I believe. Let's go ahead and get started right away. Let's take a look at numbers 1 through 4. The directions say to describe the relationships, looking for stuff like midpoint, congruent, perpendicular lines, angle bisector, segment bisector, etc. So here we go. Let's go through this very quickly. For number 1, I notice right away that I can state that AB is congruent to AC, right? Because here's AB, has 2 marks, and so does AC. And I can also state in a big line here that AC is also congruent to BC. And so by putting all of these in a straight line, I'm really saying AB is congruent to AC, AB is congruent to BC, and also AC is congruent to BC. Okay, so there's all of my congruencies there. For the segments, angle A is congruent to, angle B is congruent to angle C. So angle A is congruent to B, angle A is congruent to C, angle B is congruent to C. And I really don't see anything else that I can make note of there with number 1. Let's move on to number 2. Well, I notice this segment here has 2 marks and this segment here has 2 marks. So that means this point right here is the midpoint. So I guess I could say that segment DE is a what? It's a segment bisector because that segment right here is cutting AC right in half. I can also state that AB is congruent to BC because they're congruent segments. And let's see what else I can say. I can also say that point B is the midpoint. So B is the midpoint of AC. There we go. Pretty simple. Moving on to number 3. And we got a lot of stuff here. Okay. Angle ABE is congruent to angle CBE. See how there's 1 mark here and 1 mark here, so I know this angle here with 1 dot and this angle here with 2 dots. I know those 2 angles are congruent to each other, so angle ABE, this angle right here, is congruent to angle CBE, this angle right here. Okay, let me clear all that off and let's continue on. Let's see, also for number 3, I can state that AB is perpendicular to DC. And by the way, you could say DC, you could say CB, you could say BD, BC. Any of those 2 letters on this segment would define that segment. And let's see what else we can state here. Angle D. Okay, here we go. Angle DBA is congruent to angle ABC. Did you see that one? That's interesting. Angle DBA is a right angle, and also angle ABC is a right angle. Think about it. If you have a straight line like this, and then this line here is perpendicular, that means I have a right angle here and also a right angle over here. So those 2 angles are also congruent. Let's see, what else could I state? Segment BE is the angle bisector of ABC. So this segment right here is bisecting this big angle right here. Okay? So I could state this. I could say segment BE is an angle bisector of angle ABC. Okay, moving on to number 4. Let's see, number 4, I could also state, let me look it over here. D is the midpoint. D is, well, that's really good, isn't it? There we go. D is midpoint of segment AB. Alright, so here's segment AB. Watch it carefully. Here's segment AB, that whole segment. And notice from here to here, I have 2 marks. And from here to here, I have 2 marks. So D is right in the middle. So D is the midpoint of AB. I could also say, because of that, segment AD, D is in dog, that's a D right there, AD is congruent to segment DB. I could definitely state that. I could state that angle CDB is congruent to angle BDE. And let's take a look at that. Here's angle C, D, and then B. That angle there in black is congruent to angle B down to D and E, because there's one mark here and there's one mark here. So I can definitely state those two angles are congruent. Let's see if I can state anything else. How about this? Angle CDA. Angle CDA is congruent to angle ADE. And let's highlight those for you. Angle CDA goes like this, here, and then here, okay? And then angle ADE. So here's A to D and then to E. So we're saying this angle right here is congruent to this angle over here. Now you're probably saying, how do you know that? Mr. Earhart, well, let me show you real quick how I know that. Think about this for a second, students. Here's a straight line right there. And I have a line coming off of it here and a line coming off of it here in such a way that this angle right here is congruent to this angle here. So let's pretend, just watch this. Let's pretend this is 30 degrees. Just pretend, okay? And let's pretend this is 30 degrees. Well, students, anytime you have a straight line and a line coming off of it, and this is 30, then this angle right here has to be 150. Think about it. A straight line always equals 180 degrees. So if I have one angle here with one dot and one angle over here with two dots, those two angles have to add up to 180 because I have a straight line right here. Now, do I know for sure that this measurement right here is 30 degrees right here? No, but I'm trying to help you see this a little better. If this is 30, then what does this angle right here have to be? 150. And if this is 30, what does this angle right here have to be? 150. And so that is why we can state angle CDA is congruent to angle ADE, okay? That's a tough one. I hope that made sense. And let's see, what else? I'm trying to look this over here. What else can we state? BD is the angle bisector. So BD is angle bisector of angle CDE. And that's true. Here's angle CDE right here. Here's the big angle. And this segment right here coming out cuts the angle right in half, okay? And so there we go. Moving on to number 5. Let's find the distance of AB. If you'll look in your directions, A is -1, 4, and B is 3, -1. So let's find the distance of AB. Let's find the distance of AB. So here we go. X minus x, -1 minus 3, quantity squared, plus y minus y, that's 4 minus a -1, quantity squared. And so that's a 16 plus a 25. And if you add, well, let me slow down. A -1 and a -3 is -4. Square that, you get 16. 4 minus a -1 is 4 plus 1 is 5. Square 5, you get 25. Add those two together, and you get the square root of 41. Okay, so the distance of AB is the square root of 41. Okay, let's find the midpoint of AB. First of all, we know that A, according to the directions, is -1, 4, and B, according to the directions, is 3, -1. All right, there we go. So with that in mind, let's find the midpoint. We would have x plus x divided by 2, so -1 plus 3 divided by 2, comma, and then y plus y divided by 2, so 4 plus a -1 divided by 2. And let's see what we would get. -1 plus 3 would be 2. 2 over 2 is 1. And then 4 plus a -1 is 3. And 3 over 2 would be 3 halves. Or you're welcome to put 1 and 1/2. Or you're welcome to put 1.5. I'm not sure why I put a 5 there, but let's fix that real quick. 3 halves. Okay, so there's the midpoint. Not too bad. Okay, moving on to numbers 15 through 22. We're going to use this figure right here to answer these questions up here. So number 15 asks, what is the midpoint of AE? Well, here's AE. and obviously just by using just the naked eye, just estimating, it looks like C would be the midpoint. Okay, so let's go ahead and see if that's correct. Yes, it is. C is the midpoint. Okay, number 16, I want to know the ray that bisects angle AEI. So here we go. We're going to go from A, angle AEI. What ray bisects that angle? Well, this one right here, KE or EK, however you want to say it. So let's see if that's correct. Let's take a quick look here, make sure we got that right, and it looks pretty good. Moving on to number 17. 17 says we want to look for a line that's perpendicular to CI. A line perpendicular to CI, and that's going to be line, here's CI right here, and the line perpendicular to that would be this line segment right here, AE. Okay, so let's move on. That should be correct, AE. All right, number 18, a point that lies in the interior of angle IAE. So here's I, down to A, and over to E. So we're looking for points that lie in the interior of this red angle. Well, P lies in the interior, and G lies in the interior. So the answer could be P or G. Sorry about that, students. P or G, either one of those two would be acceptable. Okay, moving on to number 19. 5 angles that are congruent to GAE. All right, so here's G, here's A, and here's E. So this angle here, I'm just going to number them for you. This angle here would be congruent. This one here would be. This here would be 3. This one here would be, and this one here would be. Okay, so there we go. So what is the name of angle 1? Well, it's angle GAK or GAI, whatever you want to call it. And what is the name of angle number 2 right here? Well, you could call it angle AIC or angle KIC or KIP, or any of those different arrangements would be fine. Okay, what is the name of angle 3? Well, it's angle CIE or CIJ or PIG or PIE. All of those are totally fine. I'm not going to go ahead and do angles 4 and 5. Hopefully you're getting the idea, okay? So those are the 5 angles that are congruent to angle GAE. All right, number 20. 5 segments that are congruent to CA, okay? CA. Well, CE, I'll put a little mark here. CE would be 1. EG would be 1. GI would be 1. IK would be 1. And KA or AK, however you want to say it, would be 1. So there you go. There's 5 segments that are congruent to segment AC. All right, and let's go ahead and move on to number 21. 2 segments that are congruent to AG. 2 segments congruent to AG. Well, here's AG. So another segment that would be congruent to that is segment KE, this one right here. So, or EK, however you want to say it, and then also this one right here, CI or IC, however you want to say it. Those 2 segments would be congruent to segment AG. And then number 22, a ray that bisects segment EI. So let's find segment EI real quick. If we can get this eraser to work. There we go. All right, a ray, let's see, segment EI. Here's segment EI. Here's the midpoint. And so here's the segment or ray, whatever you want to call it, that bisects IE. And so we're going to call that AG or GA, however you want to say that. Okay? All right. Moving on to a couple more problems. We're just about done. We're going to find the distance between A and B from here down to here. All right. Now this ordered pair right here is over 3 and up 3, so -3, 3, And then this ordered pair right here is over 3 and down 1, so 3 comma negative 1. All right, so using those 2 points, let's find the distance between A and B. So we have x minus x, negative 3 minus 3, quantity squared, plus y minus y, 3 minus a negative 1, so 3 minus a negative 1, quantity squared. All right, now negative 3 minus 3 is negative 6, and when you square negative 6 you get 36, plus 3 minus a negative 1 is 3 plus 1, that's 4, and 4 squared is 16. So when you add those two numbers together, you get the square root of 52. Okay, and that is a great answer. That's the answer they have right here. Don't forget also, you could break 52 down into 4 times 13. Okay, and then the square root of 4 is 2, so cross off the 4 and put a 2 on the outside. You could also put 2 square root of 13 if you wanted to. Okay, and moving on to number 25. I believe at number 25 we stated, let's see here, that we're just going to find segment CE, I believe is what we said. Segment the distance of CE. And so C here is going to be 1 to over 3 and down 2, so negative 3, negative 2. And this point right here is over 4 and up 4, so 4 comma 4. So let's find the distance between those 2 points, or in other words, the distance of the segment. So x minus x, that's negative 3 minus 4, quantity squared, plus y minus y, negative 2 minus 4, quantity squared, and negative 3, negative 4 is negative 7. When you square negative 7, you get 49, plus negative 2, negative 4 is negative 6. When you square negative 6, you get 36. And if you add those two together, you should get the square root of, let's see if I made a mistake here. I'm not sure this is adding up correctly. Let's see. 1, 2, 3, negative 3, down 2, negative 2. So negative 3, negative 2, over 1, 2, 3. My bad, students. I apologize for that mistake. It's 3 comma 4. So it'd be negative 3 minus 3. I apologize for that. So negative 3 minus 3 would be, if I can get this right here this time, let's see. Okay, I'm back, just checking my work. Negative 3 is negative 6. When you square negative 6, you get 36. Add those two together, and you get 72, which is the answer the book has. Don't forget also, 72 is the same thing as 36 times 2. We know the square root of 36. You can put a 6 on the outside, and you could also write your answer as 6 times the square root of 2. Okay, moving on to number 27. I believe this is the last problem. They want us to first find the midpoint between these 2 points, and then verify that it's the midpoint by using the distance formula. So let's first of all find the midpoint between these 2 ordered pairs. X plus x divided by 2, so 4 plus a negative 2 divided by 2, comma, y plus y, so 3 plus a negative 5 divided by 2, and then we would have, let's see, 4 plus a negative 2 is 2, 2 over 2 is 1, and then 3 plus a negative 5 is negative 2 over 2, which is a negative 1. Let me check the answers and make sure that's correct. Yes, it is. And so I have found the midpoint that's between these 2 points, and the midpoint is this right here. Okay, so let's be careful now. We're going to verify this is the midpoint by using the distance formula, and we're going to go ahead and give this point a name. We're going to call it point A. So A is the midpoint. So think about this. If point A is right in the middle of JL, just pretend here's J, and here's A right in the middle, and here's L. If A is truly the midpoint, then I can find the distance of JA, and it should equal the distance of what? The distance of JA should equal the distance of AL. So let's very quickly do that. J is 4 comma 3, A is 1, negative 1, and L is negative 2, negative 5. So let's find the distance of JA very quickly. So x minus x, 4 minus 1 quantity squared, plus y minus y, 3 minus negative 1 quantity squared. And I would get 4 minus 1 is 3, 3 squared is 9, 3 plus a negative 1 is 4, 4 squared is 16, 9 plus 16 is the square root of 25, and the square root of 25 is 5. So hopefully we're going to get 5 out down here also for the distance of AL. Okay, so let's see what happens. Distance of AL. Well, x minus x, so 1 minus a negative 2, quantity squared, plus negative 1 minus 5, quantity squared. And let's see what we get here. Hopefully we're going to get the same thing. I'm having my concerns here that we're not going to. And I'm back, students. I noticed that right here is supposed to be negative 5, so I forgot to put that negative 5 right up there. So let's do that quickly. That's going to make all the difference in the world. Now I have negative 1 minus a negative 5. There we go. And now let's see what happens here. 1 minus a negative 2 is 1 plus 2. That's 3. 3 squared would be 9. Plus negative 1 minus a negative 5 is negative 1 plus 5, which is 4. And 4 squared is 16. 9 plus 16 is 25, and the square root of 25 is 5. So yes, we did verify. I mean, we already knew this was the midpoint, but we just wanted to verify it and make sure by using the distance formula, and we did that, okay? I hope this homework help video has been a help to you. Call or email if you have any questions.